In this video, we're going to explore long-term memory or a GPT using SQLite as its vector store. We'll talk more about this chart, but let's first see how it works. When we first start the program, we get a GPT and an entity extractor initialized. We are using OpenAI unified class that I've written. It also automatically creates a chat history DB, which is currently empty. This is where its long-term memories are going to go. We have a parameter called always remember, which is set to true. So we will be performing memory search with every interaction. And the GPT's current actual conversation history is actually set to 0. So that means other than the long-term memories we're going to be forming using embeddings, it will have no recollection of the ongoing conversation. Code files for this project will be available at my Patreon. Link will be in the description. I have prepared some statements such as, hi, my name is Echo, and some secret words and some stuff that we would like it to keep track of. And then I have questions which we can use to probe its memory. I'm going to go ahead and copy these one by one instead of trying to type it out myself. So when I say, hi, my name is Echo, it says, hello, Echo, how can I assist you? I'm going to go ahead and start pasting these here. And while these are happening, as you can see in our vector store, our memories are being formed. Currently, we have 2 memories plus their embeddings. And you can see we have a third parameter called processed, because I put in a special parallel threaded system where once the 3 memories are formed, then we do entity extraction on them and delete the 3 memories and replace it with the entity extracted versions of them. So we treat this code, which we will review after this demo, as a proof of concept. It has a lot of cool features, and you can actually modify it to work exactly as you are looking to. I'm going to go ahead and put the third statement, which says second secret word is apple. The previous one was first secret word is plum. Now this is going to form our third memory. And as you see now, we have 3 memories, and a parallel process was automatically initiated. And it actually extracted the entities and removed those 3 with its embeddings, with the extracted entities and the embeddings, and the entities are name, the first secret word, and the second secret word. So this is supposed to happen every 3 memory points. Let's go ahead and continue. If you are enjoying my projects, you'll have access to over 200 of them at my Patreon, which is a result of over 2,000 hours of effort in the last year. And I put in 30 to 50 hours of coding every week to output 8 to 15 new projects, which my patrons have access to. Thank you for your support. Let's get back to the code. I can just continue quickly, just copying and pasting. Now this makes 6 actually. And you can see the other memories are being formed, but they're not processed. And when we receive the third one, we should convert it into an extracted entity structure. Okay, continuing. I'm just going to go ahead and do these, and I'll be right back. Okay, I've gone ahead and inputted all. The last one is being processed. And we have actually converted all of them to their extracted version. So these are all our memories now. As we talk with it more, it's going to form more memories. But here are some questions. For example, we can go ahead and ask, what is the first secret word? Remember that it has no memory other than what it can retrieve from its memory base. Let's see what it says. The first secret word is plum, which is correct. Let's go ahead and ask the second secret word. And it correctly says it's an apple. And it is also forming new memories with this. So keep that in mind. We are always forming new memories, and we are always retrieving in the setup. What should you say on the first day of summer? It's a happy summer solstice. And actually, it was the sun embraces us all. So that's what it said. Maybe it's also confabulating a little bit. What song should you learn on the guitar by November? Oh, I actually accidentally pasted the wrong thing. Let's try this again. What song should you learn? Blackbird by Beatles, which was the song to learn. At least that's what we put in. How does the secret handshake go? Oh, again, I'm inputting the wrong thing, but nevertheless, how does the secret handshake go? Involves tapping over your nose twice, followed by a double high five, which is what it was. And as you can see, we are continually forming new memories. So we will be reviewing the code shortly, but let's take a look at the diagram that I built for this to see how it works. First, we take in a user input, and we always take this user input, and then we get its embeddings, and then we input it in our SQLite vector DB memory as one of these individual memories. And if our database is not empty, then we retrieve the memories. But in the first case, we won't have any memories. And then we just simply get a response from GPT like this. Now, the second time we enter a user input, then again, we are getting its embeddings. We get a response. I forgot to mention. So we get the user input plus the response. Then we actually embed it together, user input plus response into embeddings. And then that's how we store these memories. So each memory point is a single exchange of conversation, user input plus the response. So this first thing I was actually mentioning is the getting of the embeddings for user input so we can perform similarity search and then get the top end memories and then send it to GPT for a response. So in the beginning of the code, we initialize the GPT chat class using unified OpenAI and then an entity extractor, which is running on a separate parallel thread. And it continuously looks for the SQLite's unprocessed memory base. And if it sees 3, then it actually extracts the entities and then combines them into an entity, gets its embeddings, and then replaces this 3 memories with these entities and its embeddings. And then this whole process keeps going on. We take in user input. We retrieve any memory that is associated with it, and then we get a response. We get the response, combine it with user input, and then we create the embeddings and put it into the database. An entity extractor is continuously watching to extract the entities for future round of conversations. You can easily find all my projects at my website, echohive.live. And if you're a patron, you can find the code download links here as well. While you're there, make sure to check out the Auto Streamer, which is an app I created, which auto-creates content, allows you to record it or live stream it. And it builds a course website in real time. You can watch the live stream I did, showcasing its abilities. You can also see the sample website it has built. This is the website we had built during that live stream.
NumPy introduction and arrays.
You can also use this website to brush up on your Python. I also created this fastpython.up.railway.app, which is deployed at Railway, which allows you to quickly check out some Python concepts. It's a pretty cool app. It's available at this URL. I'll put it in the description. So this might at first seem pretty complex. That's why let's start with a basic code example, which actually uses JSON file to keep track of the memories. This one works pretty similarly, except for the fact that it doesn't do entity extraction. So let's see what's happening. We are using GPT calls class from OpenAI Unified, which is a class I created with some useful methods of keeping message history, clearing history, and some nice methods which allow you to easily actually make calls to GPT, both with JSON mode and streaming through and otherwise. I'll be talking about the methods that we use in this example, but if you want to know more about OpenAI Unified class, then please watch this video. Link will be in the description. So we import GPT calls and we instantiate the GPT chat with max history words set to 0, so you won't maintain any message history. And we give it a system message using the add message method, which just simply manages the messages list based on role and content. The system message is going to say, you are a helpful assistant. Do not refer to your memory unless it contains information relevant to the conversation. I did say this because at every turn we are doing retrieval from the long-term memory. That's why sometimes, it might just start reciting it, even though it's not related to conversation. We are defining a function, which is going to take in some text and its embeddings, and it's actually going to write it to a JSON file. And it's going to look like this. I'm going to actually go ahead so we can create a new one. The load to data frame is actually going to check if chathistory.json exists and load it into a pandas data frame and return it. Find top and similar is going to be our similarity search method, but since we need to search over the entire data frame, this is going to take in the user input embedding, right? Which is what we're going to use to similarity search over the entire database with. And n is how many most relevant chunks we want to return. We get our data frame. We check, make sure it's not empty. Make sure that it contains embeddings. And now here we perform GPT chat's similarity search method, which actually uses cosine similarity from scikit-learn to perform similarity search between 2 embeddings, essentially, and it returns a score. Here we are actually doing it over the entire data frame, and we create a new column called similarity, and then we just sort it and return however many n we have specified in the beginning of this function. So this is just going to return the top and similar entities from this data frame. So pretty much we run an infinite loop. We load our data frame. We are just printing the head of the first 5 elements in the data frame. We take in user input, And then we get the embeddings for that user input using the getEmbedding method of unified OpenAI, which uses text embedding 3 large and pretty much just takes in a text and return its embeddings. And then we check if our data frame is not empty, then we run the find top and similar function using the user input embeddings, which we have just received, that is going to give us top similar. And then this is still going to be a data frame, as you can see. So we are actually converting it into a string. And then we use the add message of GPT chat to add it as an assistant message, just saying from previous memory, these are the chunks we have returned. And since now this is in its message history before it's being cleared, then we just use the chat method, which just actually calls the add message and get response method. And within the get response method, actually we do call the trim history at the end. So this is why, since we set the max history to 0, it will eventually clear it, but not at this point. So we're going to get a response based on the memories that are provided with our similarity search. And then now we have our user input plus the response. We combine it like this into user input plus response, and we get its embeddings. And then we save that using the save the JSON. So when we run this, you will see what's happening. See, we are printing the data frame. Initially, it's empty. You can say, hi, my name is Memo. And it says, hello, Memo, how can I assist you? And we are here printing the first element in the long-term memory. And if we were to keep saying the secret word is plum, we're going to add this into it. And you can see that our chat history is being formed into this JSON file. We are continually opening this and reading it into a data frame. And as you can see, this entire operation is pretty fast. I can ask, what is my name? And it's going to say your name is Memo. I can ask, what is the first secret word? And it's going to say mention is plum. So it's continually retrieving from its memory. It doesn't have any short-term memory. This is for demonstration purposes. You can actually set a short-term memory. Obviously, that's the best form of memory you can have. But this actually creates a, theoretically speaking, infinite memory for your chatbot. So that's how the basic version works. Now let's take a look at the one that works with a SQLite database. Just so you know that because our database was created from the beginning of the video, we can actually run this and it will retrieve those memories. So it's a continuation of our previous conversation pretty much. We can again ask what was the second secret word, and it should say apple. Hopefully the second secret word is apple, and it is retrieving and it's still creating memories into this chat history. So here again, we are using GPT calls and we are using threading and we are using SQLite for our database. We create a DB path. Number of rows for entity extraction is going to determine how many rows of unprocessed memory information to be accumulated before we actually convert them into an entity extracted version. I'll close this. That's what it does. Number of similar entities is how many do you want to return for each turn. Always remember is set to true. So this way it'll perform a retrieval from its long-term memory at all times. If you didn't want it, if you wanted to set it to false, then you would have to type in remember in your message so that it'll perform this step. For example, if I were to set this to false and then rerun this, it will still have access to these memories, but it won't be able to remember them unless we ask it to, unless we use the word remember as a command. That's why I named this commanded long-term memory. For example, if I say, what is my name? Let's see, I think it should not, I don't have access to personal information, so it doesn't remember, but I can say, remember what my name is. And your name is Echo. Remember in the first version, that's what we said. So remember, this triggers if you don't set always remember on, then only if you mention remember in your message, then we trigger the retrieval from memory. So those are what those are for. We again initialize GPT chat using GPT calls, max history set to 0, max word per message set to 30. So this is a soft instruction to GPT using GPT calls method rather than using max tokens. So it'll return, give or take, concise or precise length responses to you. You actually download GPT calls and take a look. We are appending, please use this many words or less using that parameter. I find this better for a lot of use cases. So because max tokens will actually make the response get cut off. Plus, if you're using JSON mode only, then your JSON object won't be properly formulated. You won't run into that issue if you use the soft instruction like this. System message is the same. We do say do not refer to your memory unless it's relevant to the conversation. We instantiate a GPT entity extractor. It's JSON mode set to true, streaming set to false because we don't want to print the entities being extracted during live chat. Max history words is 0, and we just give it a name. It's system messages. You're tasked with extracting important entities from the chat history so we can store them in the long-term memory. Only extracted entities which seem relevant to the current user input response pair. Yeah, only extract entities, should say here, that are relevant. And then please return your response as a JSON, just like this. So we instantiate a lock also from threading because we are going to use a separate thread, and both the original thread and the secondary thread can write to this SQLite DB. And to overcome race conditions and whatnot, we're going to use threading.lock, and we're going to perform our save the database operations with that lock, also in the thread as well. So we have a function that's going to just set up the database with the proper column names, such as user input plus response, embeddings, and the processed column, which is going to be Boolean. So this just creates it. Save the database is going to connect to the database. It's going to take in user input plus response and embeddings, and process is going to be false. But we're going to be converted, that's by default, but we're going to be changing that as we process. This just writes the information to database. And on this function loads it to a data frame, pandas data frame, and returns df. Normally speaking, since we're going to perform simulated search over the entire database, you probably don't want to do it with SQLite. The pandas is just going to be so much faster. Before I continue, I do want to mention another one of my apps that I built called CodeHive. It's at codehive.app. You can find the link in the descriptions. And it contains over 900 plus GPT-powered Python chat applications. You can simply browse or search for the kind of stuff you're looking for. And here's the code. You can copy it and paste it and run it. This is good to get some inspiration or even some business ideas. Just take a look. And if you do like what you see, it's a free app. But if you do like what you see, you can download all of the apps from my Patreon for only $100 currently. So continuing on the code, we have the process and replace last n rows. So this is the part that we're going to run in the separate thread, which is going to take in a df. Obviously, we don't really have to do this, but anyway, and we get the unprocessed parts of the df. Then we get the last n part of the tail of that df, depending on how many we have specified, number of rows for entity extraction, converted to a string. We extract the entities using the entity extractor. We get its embeddings, and then we convert it to JSON because SQLite, if you want to store large embeddings in SQLite, you can. It turns out you probably want to use a different type of object, such as blob or like JSON. Here in this case, we're using JSON, and with write.lock for threading, we have specified we perform the database operations. This next function, find similar n, is just going to do the similarity search and return our top, sorted database, sorted and return based on how many number of similar entries we have defined in the beginning. And to begin our script, we are setting up the database by calling that function, which we have defined all the way in the beginning. Then we enter a while loop, taking user input. We get our data frame, and we check if remember command was entered, or if always remember is on, and also making sure that the data frame is not empty. We perform similarity search, and we add it to our chat bot's history momentarily. Then we get a response. We combine that response with our user input, get the embeddings, and save the database. And then again, we load the data frame because now we're going to submit it to the process and replace last n rows. And its argument is going to take in that df, and we start that with threading.thread start. As far as I know, this is pretty thread safe. I think as long as you do start your thread with .start and give it a function, as soon as this function stops processing, your thread should end. So this is how we are able to keep track of a infinite long-term memory with a SQLite in some very simple logic, and even use entity extraction to reduce the size of our long-term memory and actually keep track of entities in a neat way. Now, this is not perfect. Entities eventually might start being confused. So you might have to implement some more complex logic to actually extract entities from even a larger surface area. to make sure that since we are only retrieving top 3 similar entities, that entities don't replicate each other, because when you actually mention something and when you ask for that thing, will form a memory as well. And that's why I hope that makes sense. But like I said, all the code files, including the OpenAI Unified, which really simplifies your life to a great extent, will be available at my Patreon. So if you are a patron, I really appreciate your support. And if you like my content, please like and subscribe, and I'll see you in the next video. You can easily find all my projects at my website, echohive.live. And if you're a patron, you can find the code download links here as well. While you're there, make sure to check out the Auto Streamer, which is an app I created, which auto-creates content, allows you to record it or live stream it, and it builds a course website in real time. You can watch the live stream I did, showcasing its abilities. You can also see the sample website it has built. This is the website we had built during that live stream.
NumPy introduction and arrays.
You can also use this website to brush up on your Python. I also created this fastpython.up.railway.app, which is deployed at Railway, which allows you to quickly check out some Python concepts. It's a pretty cool app. It's available at this URL. I'll put it in the description.